Here also we find eigenvalues and eigenvector. This is our second type. Second type name is symmetric matrix with non-repeated eigenvalues. Previous type name is non-symmetric with non-repeated values. This type name is symmetric matrix with non-repeated eigenvalues. Our first sum, find the eigenvalues and eigenvector of the matrix. Matrices 7, minus 2, 0, minus 2, 6, minus 2, 0, minus 2, 5. Our first step is find characteristic equation. This matrix is 3 cross 3 matrix. So our format is lambda cube minus s1 lambda plus s2 lambda square plus minus s3 equal to 0. Here s1 is sum of main diagonal elements. Our given matrix diagonal element is 7 plus 6 plus 5. Adding these values, our solution is 18. Next, S2, a sum of minor of main diagonal elements. Using this type, we find our solution is 99. Next, we find determinant of A. So, our solution is 162. Applying this S1, S3, S3 in given format, lambda cube minus 18 lambda squared plus 99 lambda minus 162 equal to 0. Next, we find roots. Using synthetic method, we find roots. First root is 3, second root is 6, third root is 9. So, our characteristic roots or eigenvalues are 3, 6, 9. These three eigenvalues are different. So, non-repeated eigenvalues. This means non-repeated eigenvalues. Our given matrix is symmetric matrix. Symmetric matrix means A equal to A transpose. Next step is we find eigenvectors. Our format is A minus lambda I into x equal to 0. Our A is 7 minus 2 0 minus 2 6 minus 2 0 minus 2 5 into x1 x2 x3 equal to 0. Here next we applying lambda values. Our first lambda equal to 3. Our given matrix is 4 minus 2 0 minus 2 3 minus 2 0 minus 2 2 into x1 x2 x3 equal to 0. Using cross multiplication, we find our eigenvector x1. Here x1 is 1 2 2. Next, applying next lambda is 6. Applying lambda equal to 6 in equation 1. Our given matrix is 1 minus 2 0 minus 2 0 minus 2 0 minus 2 minus 1 into x1 x2 x3 equal to 0. Using cross multiplication, we find eigenvector x2 equal to 2 1 minus 2. Next eigenvalue is 9. The applying our first equation lambda equal to 9, we get minus 2 0 minus 2 minus 3 minus 2 0 minus 2 minus 4 into x1 x2 x3 equal to 0. Using cross multiplication, we find third eigenvector 2 minus 2 1. So we find our first step is find characteristic equation. Second step is find characteristic roots or eigenvalues. Our given eigenvalue is 6 3 9. Next we find eigenvectors. Our eigenvector is first eigenvector is lambda equal to 3. First eigenvector is 1 2 2. Next lambda equal to 6. Second eigenvector 2 minus 1 minus 2. Third lambda equal to 9. Our third eigenvector is 2 minus 2 1. This is our third type. Third type name is symmetric matrix with repeated eigenvalues. So our given matrix is symmetric matrix. We find eigenvalues repeatedly. So our first step, all steps are common first step. First step is characteristic equation. Find characteristic equation. Here also 3 cross 3 matrix. So our format is lambda cube minus s1 lambda squared plus s2 lambda minus s3 equal to 0. Our s1 is sum of the main diagonal elements. Our given matrix diagonal elements is 6 3 3. Adding these values, our solution is 12. Next we find S2 is sum of minor of main diagonal elements. We get answer is 36. Next we find S3. S3 is determinant of A. So our solution is 32. Apply S1 S2 to our format lambda cube minus 12 lambda squared plus 36 lambda minus 32 equal to 0. This is our third degree order. So we find root using synthetic division. Our eigenvalue is 8, 2, 2. Here 2 is 2 times repeated. So this is repeated eigenvalues. Next step is we find eigenvectors. Our format is A minus lambda I into x equal to 0. Our A is given matrix, lambda is eigenvalues, I is identity matrix. Solving this format we get C minus 6 minus lambda minus 2, 2 minus 2, 3 minus lambda minus 1, minus 2 minus 1, 3 minus lambda into x1, x2, x3 equal to 0. Next we apply first eigenvalue lambda equal to 8. We get minus 2, minus 2, 2, minus 2, minus 5, minus 1, 2, minus 1, minus 5 into x1, x2, x3 equal to 0. Next using cross multiplication, we find our first eigenvector is x1 equal to 2 minus 1, 1. Next we apply lambda equal to 2. We get 4 minus 2, 2 minus 2, 1 minus 1, 2 minus 1, 1 into x1, x2, x3 equal to 0. Next we generate equation type. Solving these three equation we get x value is 0. So we using another condition. That condition is we take any x value is 0. So I take x1 equal to 0 in equation 1. We get minus 2x2 equal to minus 2x3. Solving this equation we get third eigenvector x2 equal to 0, 1, 1. Next we find third eigenvector. This matrix is symmetric matrix. So we using orthogonal type. This is our third. We find third eigenvector. Let x3 equal to Lmn. We consider x3 equal to Lmn. x3 is orthogonal to x1 and x2. Next using this type x1 transpose x3 equal to 0, x2 transpose x3 equal to 0. We get two equation 2L minus m plus n equal to 0. 0 into L plus m plus n equal to 0. Using these two equation, solving third eigenvector is x3 equal to 1, 1 minus 1. So our eigenvalue is 8, 2, 2. Eigenvector is 2 minus 1, 1, 0, 1, 1, 1 minus 1. Thank you.